Thank you for joining week 7 problem solving session for the NPTEL course on environmental impact assessment being taught by Dr. Harshit Shoshin Lakra, Assistant Professor at the Department of Architecture and Planning, IIT Roorkee. This is session 1 for Saturday, 18th March 2023. I'm Isha Rathore, PMRF, and research scholar at Department of Architecture and Planning, IIT Roorkee. There's another session on Tuesday being taken by Miss Monica S., another PMRF and Research Scholar at Department of Architecture and Regional Planning at IIT Kharagpur. Since the recording for this part did not contain any audio, I am re-recording the session for the first half of the week 7 problem solving session. So we'll skip through this. So we're going to discuss the highlights from week 7's content and look at the key takeaways from the lecture units in week 7. And then we will go through the assignment questions, which include the questions for from previous round of NPTEL course and the solution to assignment 7 questions with the explanation to the answers. As the deadline for week 7 assignment has passed, we will look at the solutions to week 7 assignment problems as well. And if we received any queries from you in the discussion forums, we will also clarify those queries. So week 7 was about public involvement in AIA, and we will look at the highlights from week 7. So lecture 31 talked about AIA methods for air assessment, part 1. So we here we looked up at the definitions and concepts around air assessments in EIA. So as we know, there are several drivers of environmental change, and these include population growth and demographics, urbanization, economic development, new technological forces, the threat of climate change, and the effect of air pollutants on human health has been identified to cause inflation, sensitize and scar the airways, can affect lung in extreme conditions or due to long exposure to air pollutants and harmful gases. It can also reside permanently in body. These air pollutants can be absorbed in the body like particulate matter, uh, and they can also contaminate foods and drinks which we consume. They can also, these impacts can vary from causing mild irritation to serious illness or even in some cases. And we know that air pollutants impact the natural and built environments from causing leaching, causing the leaf decomposition to happen faster, and these pollutants being trapped in the articulating waxes of these uh, biological leaves and things. And these air pollutants being discharged back into the environment as acid rain, which kills plants' life, pollutes the rivers and streams, erodes stoneworks, affects the water ecosystem, the soil ecosystem, uh, and things like that. So these air pollutants impact the natural as well as the built environment, apart from the human health and well-being. And we looked up at the definitions of uh, critical levels and critical loads for air pollutants. So, ECE in 1996 defined air pollutants critical levels as concentration of pollutants in the atmosphere above which direct adverse effects on receptors such as human beings, plants, ecosystems, or materials may occur according to the present knowledge. Whereas a critical load for air pollutants is defined as the quantitative estimate of exposure to one or more pollutants below which significant harmful effects on specified sensitive elements of the environment do not occur according to present knowledge. So critical levels are when these concentration of these pollutants can cause direct effect to receptors like human beings, flora, fauna, ecosystem components, and materials. Whereas critical load is the estimate to exposure to these air pollutants below which harmful effects are known to occur, below which these harmful effects are not occurring, but after this critical load point, they will start occurring on the receptors. So we also looked up at odor causes from sources of odor like cooking, animal origin, rotting or putrid, burnt or smoky, and these can further be divided into other things like burnt rubber, burnt plastic, and other things, chemical or solvent, vegetable origin, hydrocarbon fuel, that is use of gas or petrol, diesel. So all of these have distinct and different smells, but these are all causes of odors, being divided into sectors and categories, and further subdivided into the type of activity that is causing the odor. Then we also looked up at the Friedel factors, which is used to assess the effect of odor. So Friedel is defined from the first initial letter of the five factors, which is frequency. That's how frequently is the odor detected? Is it being continuously felt or daily or infrequently? Intensity is how strong is the odor, ranging from very weak to extremely strong. Duration is how long does the exposure last? Is it seconds or minutes or hours? Offensiveness is how unpleasant is the odor, ranging from very pleasant to very unpleasant. Location is where was this odor experienced? Was it in a home setting or a business setting or a roadside setting or an amenity place? So Friedel factors are used for assessing the odor odor effects. And then we also had ambient air quality guidelines and standards for human health. So WHO Global Air Quality Standards. So the WHO defined for all countries to achieve recommended air quality levels, and these are based on the health aspect for human beings and the environment. So as you can see that the WHO has revised its guidelines from very broad to being very stringent from in the year 2005 to 2021, and we can see the concentration, the annual concentration of air pollutants like nitrous oxide, particulate matter 2.5, particulate matter 10, and ozone. So we can see that the guidelines have become more narrow and stringent to being reduced from 40 microgram per meter cube of nitrous oxide to 10 microgram per meter cube of nitrous oxide in 2021. And then we also have the International Finance Corporation IFC Performance Standard, that is the Performance Standard 1, which is on risk management. So, this is an international benchmark for identifying and managing the environmental and social risks. And we also have the National Ambient Air Quality Standards, or the NAAQS, which are standards for ambient air quality set by the Central Pollution Control Board, or the CPCB. And this they defined ambient air quality standards, which contain 12 pollutants from being like sulfur dioxide, nitrogen oxide, particulate matter 10, 2.5, ozone, lead, carbon monoxide, ammonia, benzene, benzoparticulate phase only, arsenic, and nickel. And they defined their measurement time in terms of time weighted averages and their concentration in industrial residential and rural areas as an ecologically sensitive areas. Methods of measure for these air pollutants. And so these are the recommended levels on an annual basis for air in these different areas as defined by the CPC in 2020. And we also have the examples of critical levels for the effectors and for measurement and critical levels. We have all similar air pollutants as defined by India as well. But the measurements are again different. They also measure it on crops, forests, and natural vegetation, on legends, and other natural. And then for guidelines and standards developed in the different countries for measurement of odor. So, for example, we have measurement of odor in UK as the odor concentration is expressed in terms of European Odor Unit, or OUE. So, one OUE is the threshold where 50% of the members of an odor panel can detect an odor in laboratory conditions. So, if 50% of the members can detect an odor, it is equivalent to one OUE. And we have the Institute of Air quality management IAQM guidance from the UK, where the different suggested odor effect descriptors based on the receptor sensitivity for ranges of concentration. So there are different sensors for monitoring at different places like demolition, construction site, bodies, and how we need to identify the pollutants and their anthropogenic sources or human activities which are uh, causing the environment or releasing the air pollutants in the environment. So, for example, carbon monoxide is generated because of fuel combustions by human beings, and volatile organic compounds or VOC, that is benzene, which is also harmful and toxic, is a result of petrol engine vehicle exhaust leakages at petrol stations, paint manufacturing. Similarly, toxic metals like lead and cadmium are generated from metal processing, waste incinerators, oil and coal combustion, battery manufacturing, cement and fertilizer productions. Fluoride also comes from manufacturing. Greenhouse gases like carbon dioxide and methane come from fuel combustion, especially power stations. Methane comes mostly from coal mining, gas leakages, and landfill sites. Ozone comes from secondary pollutants formed from volatile organic compounds and nitrogen oxides. Then we also have odors, which come from sewage treatment plants, landfill sites, chemical plants, oil refineries, food processing, paint works, brickworks, plastic manufacturing, commercial kitchen. So these are the sources of the key pollutants and the human activities which are generating these key pollutants. So we need to identify the type of activities which are happening in a project and their resulting air pollutants. And then we also have several institutions and organizations which provide data for the measurement of air, which measure the concentration of the pollutants in the air. So in India, we have the Central Pollution Control Board or the CPCB. So it measures the concentration of major air pollutants across the different years and across the different cities of the country and their concentrations. Then we also have the Automatic Urban and Rural Network in the UK, or the DEFRA, which is the Department for Environment, Food and Rural Affairs. Similarly, they measure the concentration of uh, these uh, key air pollutants in the UK across the different years. We also have the US Air Quality System, or EPA, from the US, measuring again the percentage above or below the uh, uh, these standards for the different years. And then we also have the World Air Quality Index portal, which measures the air pollutants and the air quality at different locations across the world. And then in the scoping and baseline studies for on-site pollution monitoring, data collection should be planned and initiated during the scoping stage. And the key questions which need to be answered during this monitoring phase is what pollutants need to be monitored, what type of monitoring equipment is required, the number and locations of sampling sites in the project, the duration of the survey, and the time resolution of sampling, that is how frequently you are collecting this air pollution data, whether it is every 7 hours or 24 hours or whether every 2 days. So you need to decide that time resolution of sampling. And for the equipment to measure air pollution concentration is again dependent on the intended use of the data, the budget allocated to the purchase or hire of the equipment, and the expertise of the personnel available to set up and maintain the equipment, and in some cases to undertake laboratory analysis of the collected samples. So all of these factors play a significant role in determining the uh, equipment. And then for taking the measurements, you need to consider the need to protect against vandalism, especially in a country like India. Also, we need to know and decide and to avoid pollution from indoor and localized sources, which may make the data unrepresentative of the wider area, and the availability of power supply if it is needed for any of the equipment to function and to take recordings. Most of these data is collected by individual units, and they have their own battery park or their supporting uh, infrastructure, so such that they do not need a power supply. But if it's a requirement for the instrument, it needs to be considered. So if you're using this data for modeling, you should locate them in the location close to point of interest. These passive diffusion tubes are simple, they are inexpensive devices which can be used to measure high concentration pollutants, and they can be placed very easily, and they're very inexpensive. So you can put them on poles, you can put them, you also have similar things that you can put in plants as well. So you have diffusion direction, and you measure the concentration of the pollutant based on these diffusion tubes. And they have bioindicators like lichens and funguses, which can determine the amount of sulfur dioxide which is present in the air. The presence of bioindicators on plants or on surfaces indicate that that the area is affected by high pollution of these of the key pollutant, which the bioindicators represent. So lichens and tobacco plants have both bioindicators. Then we also have this national pollutant inventory, which keeps these data for emissions and air pollutants. Okay, moving on to lecture 32, we looked up at TIA methods for air assessment part 2. So here we look up at physical models and expert opinions. So this is a example of a tunnel with a physical model being present in it. So in a wind tunnel, you can simulate actual site conditions from very high velocity speeds, wind speeds to low wind speeds, and you can actually observe the movement of winds through the different buildings and the built form. So these wind tunnel experiments are physical model experiments which can be used for determining the movements of winds and where wind is stagnated, and whether the uh, how air moves on a site. And then for the expert opinion is like a predictive method. So it is important in the process, particularly at the early stage of design. Of course, this is important for any type of project, and this is cost and time effective, where you just ask an expert on his opinion on the air quality of the site and their observations on air movement. And then we have mathematical models like numerical dispersion models. So through these models, we can calculate how specified emission rates are transformed by the atmospheric processes into pollution concentrations at different distances from the source or sources of pollution. And these patterns can vary with the atmospheric process of dilution and dispersion, and they can also be transformed sometimes because of the chemical and photochemical processes. And these models are also used for predicting pollution concentrations for emissions from a single point source, and also from emissions from a large number of point sources simultaneously, like on settling tanks, open cast mines, or quarries. So again, pollution source can be of different types. So for example, a single point source is something like a chimney or the furnace, which is releasing air pollutants into the atmosphere, whereas a line source can be something like a runway or a railway line or roads, highways. So these are line sources because they are linear sources which have continuous moving cars, which generate air pollutants. Okay, and then again, numerical dispersion models can be of two types. They can be simple or screening models, which require very basic inputs being fed into a model, and it gives you a very generalized overview idea of the air quality and air movement. And then you have complex advanced models, which uh, very fine and detailed, very detailed study of the air movement on the site. So examples of screening model is the US EPA Screen 3 air screen, and examples of complex model is CalPUF or RMOD dispersion models. Then we also have different models and their impact predictions. So we have ISCST, so this is appropriate for point, area, and line sources. and these are applicable for flat or rolling terrain, useful for transport distance up to 50 kilometer, valid in computes for 1 hour to annual averaging periods. It can take up to 99 sources of air pollutants, and it can compute concentrations on 600 receptors in Cartesian or Cartesian system, and can take receptor elevation. It requires source data, meteorological and receptor data as input. So again, all of these different models have different requirements in terms of the number of sources which they can take as input, in terms of the concentration and the number of receptors on which they compute these concentrations. Uh, so the height of the receptor or the receptor data on the source, meteorological and receptor data in terms of the distance up to which they can model. So all of these different models have these different categories. So you can go through them. So all of these are these different models for different activities. Some of them are suitable for flat terrain. Some of them can model multiple things together, but they are unsuitable for certain things. So you can look at that. So all of these are models for impact prediction. Okay, and then we also looked up at the principles of air pollution dispersion modeling. So we have the Gaussian model. So we have a plume, which is basically this volume of air pollutants, this conical volume of air pollutant being discharged and from a furnace or a stack. And then we define this plume center line, which is the central line for the plume. And so the concentration of the air pollutant is highest at the center, and it disperses towards the edges because of dispersion on the edges and its distribution to the surrounding air particles. And then the wind speed also is maximum at the plume center line, and it decreases towards the edges of the plume. Okay. And then we also look up at edges. So edges are basically when the wind moves, it moves from a pressure. It so when the wind is moving because of the presence of an obstacle, it leads to the creation of this negative pressure zone. So it causes the movement of wind to form like a circular edges. So these are edges which are caused because of the creation of negative pressure zone because of the presence of an obstacle, because the wind is not directly passing through this area, but this is low pressure zone. And then we also have low traffic uh, air pollution models like U8, the USDA's Cal 3 QHC, full models, and there's a other proprietary model which is NV. Then the line source we specify the source intensity of the it is giving out. In terms of meteorological data, you need to give data about the wind speed, the wet bulb temperature, the relative humidity on site, the rainfall patterns and conditions, the solar radiation received, and the cloud cover. And you also need to give data on the terrain or topography. And then to measure this, need to have something like a weather station, which is all of these uh, meteorological data measuring devices being put into one standing structure. So it measures relative humidity and air temperature through its sensor. Then it also measures soil temperature. Then a rain gauge measures the rainfall. Then we have a data logger which stores all the data recorded from all of these sensors. We have the sensor which is the wind vane which measures the wind direction, and the energy sensor. So all of this data is stored by the data logger, and it can be extracted in a SD card to your computer again. So this is one of these data requirements and data measuring devices. Then for odor, we have odor effective assessment methods. So we have predictive methods that are again subdivided into risk-based assessments, semi-quantitative assessments, and dispersion modeling. And so moving on to lecture 30, we have EIEA for water assessment. So here we look up definitions and concepts. So we looked up at development activities to affect the water budget. So things like evapotranspiration, which is uh, the loss of water by grass, trees, uh, and other natural things, rivers, streams, and then increase in the runoff rate, that is the water being discharged to the drainage system, recharging the groundwater and being absorbed by the soil. Reduction in the infiltration to the discharge to the discharge cycle at a at the correct rate. The reduction in indoor surface do not have the capacity to transfer the surplus water which is generated. So these are all development activities which affect the water budget. And then we also looked up at the potential impact on river systems. So when we train rivers and marshes for development purposes, the runoff increases on land. So the aggregate of water for domestic purposes, industries, and agriculture purpose, and it reduces the flow. This also impacts the availability of water in the downstream of rivers and also affects the aquatic ecology and how sediments transport through the system. Discharging wastewater from treatment plants can also change the water quality of the river systems and cause eutrophication things. Uh, 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 Then we also looked at concepts referred to as base flow. Then we also have this base flow contributes to the river flow, and it varies significantly with the geology and topology of a catchment and with the season. Then we also looked up at return period, the commencement. So this is the changes of the flow of occur, and this is a statistical analysis based on measured historic data from weather station and from rain gauge. So we look, a return period tells us the chances of the same flow of rain increasing in a year. So the return period is usually defined as 1 by P, which is where P is the probability of exceedance. So for the 2-year return period, P is half. That is, there's only a 50% chance of the same flow of rain increasing in the year. And then water budget is calculated as the calculated for a period of time, and it is usually given in depth, that is in meters, and they are presented as volume by multiplying the depth by the surface area of the watershed. And Thornweight and Mather in 1955 defined the method to estimate water as precipitation minus surface runoff minus evapotranspiration is the change in storage in the time period. Whatever the same for we are doing, groundwater, also water which has percolated into the ground to recharge the groundwater table, and minus the evapotranspiration from trees and rivers and streams and other water body gives us the total change in storage in that specified time period. This is the amount of water storage in a specified time period. That is known as the water budget, and we looked up at the development activities which affect water budget. And then surface runoff is defined by runoff curves, and curves are developed from this combination of the soil grouping and use the class of treatment. And then these daily runoff values can be collected using a device like a funnel-shaped runoff collector. And hydrological models can be used to estimate this surface water runoff. Also, because of the construction of pavements and impermeable surfaces, surface runoff has increased. For footpaths and things, we have now pavements which does not allow population of groundwater to seep into the ground and recharge the water table. So surface runoff has increased when rain event happens. Then evapotranspiration is this combined loss of water vapor from the surface of plants, transpiration and evaporation of moisture from the soil and other surfaces such as lakes, rivers, and oceans. And this is based on soils and plant types, and the amount of potential evapotranspiration can be determined based on these things. And then also we require inputs for estimation like precipitation, the temperature, and the latitude of region. So again, all water vapor loss through trees, loss, water bodies is known as evapotranspiration. So it's both transpiration and then we also looked up at fluvial geomorphology, which refers to the process of water and sediment movements in rivers and their floodplains, together with the forms produced by those processes. And these terms can be applied to environments, and this is also the study of fluxes within the river terminology. Then we also looked up at geomorphological threshold, which is a condition allowing landform stability, a dynamic equilibrium through many factors playing their coordinated role. For example, a river flowing across a floodplain is static but stable over time within that floodplain. And then we also looked up at factors which affect geomorphology, and these can be external factors like catchment form, drainage network, flora, geology, management practices, and modification, and internal controls like stream gradient, mode of adjustment, direction morphology, bed and bank conditions, floodplain connectivity, continuity, and flow. And then we also have these classification of channels as cohesive based on their geomorphological conditions. And we also looked up at the water quantity and quality in terms of surface and groundwater quality. So we have chemical attributes, physical attributes, and biological attributes, which can be explored further. And then for scoping, so for the we use a checklist method, especially a complex checklist. So we have water quality, and fluvial geomorphology here. And then we have the different activities like modification of land cover, landform, construction activities, water supply activities, waste disposal activities, and channel modification. So these are all resulting from the development of this project, which is a dam project in Pakistan. So this was a scoping exercise done for a dam project in Pakistan. And then we look up at the effect. So if it's an increase, it's a colored shape. If it's a decrease, it's a line shape, not filled. And the intensity, if it's a bigger shape, it's major contribution. If it's a smaller shape, it's a minor contribution. So we identify the different uh, increases and decreases in the water quality and quantity and fluvial geomorphology from the different construction and development activities from this dam construction project. So this is how we do scoping for water assessment. So this checklist provides different issues like surface water hydrology, river hydrology, surface water quality, erosion and sedimentation, geomorphology, and aquatic ecosystems. Then we also look about sources of impacts like storage reservoir, flow diversion, standing water, accumulation of sediment, changes in hydrology, and potential impacts on habitat, biota, dewatering, fish species, changes to erosion pattern, and then we also looked up at alternative or complementary approach to a checklist. So this is a source, pathway, and receptor model. So the source for any effect is usually the specific development activity, that is the source. The pathway is the mechanism by which that source is affecting the receptor. The receptor can be physical, human, or flora, fauna generally. So anything which is receiving this effect. So source, pathway, receptor. And then potential water quantity effects include the replacement of natural vegetated, impermeable paved area and man-made drainage system, which lead to decrease in filtration to groundwater, increased flood runoff, potential for downstream flooding and erosion. Obstructions of rivers can also cause reduced flows, leading to deposition of fine silt, channel narrowing, new development, and increase the volume of wastewater. Then water quality effects include artificial discharges to water environment. This can cause change in water chemistry. Pollutants can cause these pollutants being introduced in the water ecosystem and affecting the components of the water ecosystem. Then artificial cooling, waste discharges can also cause thermal changes, and it is a direct point source input pollution and a diffuse pollution source. And these leaching of pollutants from previously developed sites, and these can also are detrimental to the ecological status of the water body by increasing pollutants issuing from an urban area. So for water quantity assessment, we can do both desktop study and field study. So desktop study is something which you can sit and do on your desktop or on a computer. So you can access different data sources and look up at the catchment boundary area, the drainage patterns, the ridges and valleys, how the water will flow on the site, and the information on geomorphology determined from base maps, geological and soil survey maps. You can also use digital terrain models, and you can procure existing records from the different data collecting organizations to estimate the rainfall runoff models. And then you can do field studies by going to the site and doing a temporary stream gauging to determine the flow, what flow is needed. And you can use stream gauging methods and do a detailed survey data to input into your hydraulic models for modeling out the effects. And for water quality assessment, you can use existing knowledge if it's available. You can ask environmental protection agencies because they store data about chemical pollutants and on biological surveys to assess water chemistry. You can do a routine monitoring. Bathing water and surface water can be used for extraction for human consumption. And for feed study, you can do survey of rivers, biological or fishery survey. You can do group of freshwater organisms, which are used as indicators of given pollutants. You can also do biological monitoring methods. Then for fluvial geomorphology assessment, you can, for desktop study, you can look up at maps and aerial photographs. You can find out existing survey information like geologic and topographic maps. And then you can use this information and digital elevation models to calculate the stream power. And on field study, you can do a fluvial audit or a stream reconnaissance survey. You can survey the channel and do sediment analysis and use unmanned aerial vehicle technology to complete aerial survey obtaining. And then, so these are impact predictions and evaluations. So you have different sources for different activities and their potential impacts. I will not go into detail, but you can go through them at your own pace. The slides will be available on a Google Drive folder, so you can access them and go through them. These are also covered in the lecture module, so you can go to the lecture module 33 to look up at these impacts from different sources on different and their potential impacts. So something like reservoirs and dams can lead to loss of terrestrial habitats, farmlands, or settlements. They can also cause earthquake, landslides, and failure risks, and cause local climate change and rise in water table, visual because of creation of retaining walls and waterborne pathogens. Similarly, other things, laying of impermeable surface causes loss of ecological heritage and visual amenity and recreation features, and so on. And then you can look up our evaluation of impact significance. So we have the magnitude of impact. It can be major or moderate. So you have different conditions, which different conditions are measuring quantitative data and benchmarks, which determine whether the impact is major, moderate, minor, or negligible. So you can go through this and you need to do the impact significance for the effects in your impacts in your project. So you need to specify whether they are significant impacts or major impacts and so on in terms of their magnitude and both significance. And then lecture 34 was on EIA methods on soil, land, and geology assessment. So here again, we looked up at definitions and concepts. So geology is a vast and complex subject, and it concerns superficial deposits, while solid geology, so surface geology concerns superficial deposits, whereas solid geology looks up at pre-superficial formations. And there are a number of aspects to geology which are of direct importance in EIA. such as conservation, protection, and management of fossils, stratigraphy, minerals, and other geological features of concern. And geomorphology includes the study of topography of the terrain and includes the nature of rock and soil in relation to erosion and deposition, which is caused by glaciers, rivers, and wind. And human impacts can include landscape or visual aspects, but it can also include consequences such as erosion, slope failure, subsidence, and sedimentation in aquatic systems. And then land and soil. So the quality of land for agriculture and forest is determined by the combined physical properties of climate, topography, and soil. And soil contributes towards the terrestrial ecosystem services, and the value placed on land has social and economic dimensions, which is again influenced by the potential users of the land and its location in relation to the different settlements around it. And then so soil has different properties which have different significance. Texture is affected by the chemical properties and the clay contact density, whether it's suitable for root growth, and the right to permeability, then pH, which is based on the nutrient availability and other chemical reactions within the soil. It also increases the degree of weathering of the rock. Then the depths to A1, B2, impeding layers, thickness of soil and rhigosol. So these are again layers of the soil, and they are used to calculate the volumes of water and nutrients in each of these layers and the plant available water capacity, storage capacity for nutrients and contaminants. Then you also have the volumetric water content, the amount of water available to plants and for water movement, the plant available water capacity, and other things like conductivity, electrical conductivity, aggregate stability, exchangeable basis, cation exchange capacity, substrate type, substrate permeability. All of these are different soil properties and their different significances towards the quality of soil. And then we also looked up at soil profiles and soil classifications for spodosol and oxisol, two different type of soil classifications, where this one is more dark reddish in its color, and this is more organic and orange brown because of the different layers and the constituents. And then we also looked at soil fertility, which is low soil fertility and toxicity. So low soil fertile, and that is being made unavailable for plant uptake. So that's why the soil is not fertile and does not cause plant growth. And soil toxicity is because of a high level of toxic components or elements being present in the soil. So it makes the soil toxic. Then land quality has two meanings in the current environmental impact assessment studies. So it relates to the quality of undisturbed land and natural soils, their value to agriculture and forestry, and the provision of terrestrial ecosystem services. And it also concerns with the degree to which soil has been degraded or polluted by disturbance and contamination coming out of an anthropogenic activity, and the necessary remedial measures undertaken to improve the land quality. And then we also looked about methods in the scoping stage. So we looked about desk studies, field studies, and laboratory work. So in the scoping consideration, the geological or soil resources within the project impact area, whether they have significant impact or not. If they have significant impact, then can we undertake mitigation measures to reduce these impacts? And these can be in terms of land capability classification or land evaluation. Also, in terms of identifying the soil and soil conservation, is it needed to restore the land, and the possibility for using landscaping, processing the soil quality, topsoil and subsoil, and doing appropriate site investigations. So you can also use geological maps. So geological maps cover larger area, like whole continents, and they are in the scale of 1 is to 20 million. Regional maps are more specific to the region, and they are between 1 to 1 million and 1 to 250,000 scale. And for more details, you may cover 1 is to 10,000 scale. So if you look up at a particular specific area in that region, you can go to a scale of 1 is to 10,000. And then these maps can be solid or drift maps. So solid maps show pre-quaternary rocks, whereas drift maps show superficial quaternary deposits, which were laid down more recently because of wind, water, or ice. And then for desktop studies for land and soil, you can gather this information from the available sources and see how useful this data is, or whether this data is available at the national or local level, because soil differs at a very regional specific level. So you need to find a lot of published sources and find the relevant source for your specific project, and the possible land and soil type in your study area. And this preliminary knowledge can be used to plan field experiments and field surveys. Then, for contaminated land, you need to check the possibility of contamination and the source of contamination. You need to look up at historic maps, and in what in country, if in your country you have historical land use data, then you can use that and get it from a regulatory body. For you can also get geological and hydrogeological maps from them. Then for field survey, you can collect the baseline information on land and soil. You can take up samples, soil samples, and prepare sample network and density and send it to the lab for further working. You can compile information from GIS into a GIS for spatial and statistical analysis. And you can also look up information such as landform, soil types, and land quality, ground cover, crops, land ownership, and tenure. For contaminated lands, again, if you do a desk study, you can find the possibility of contamination. You can do a walkover survey to identify the stretch which is contaminated. You can do initial project planning. Uh, and if the contamination is confirmed, you need to identify these sources to be a part of your baseline study. For lab work, you can send for lab evaluation and they do soil texture and pH analysis. And these lab studies can be used in the EIA process for baseline studies, for land evaluation, mitigation measures, and analysis during project construction operation for monitoring and management purposes. And they have different particle size identification as well. And then again, methods of impact prediction for land and soil. So these are analysis techniques. So for methods on impact prediction, you can use uh, digital analysis techniques. So you can use land use or land cover distribution. You can use ranking analysis for soil suitability criteria, which provides suitability for development or construction activities. And they do assessment on various parameters like depth, texture, slope, erosion, status, geomorphology, flooding hazards, groundwater potential, land use, etc. And you can also look at affected microflora or microfauna at the site. And then the evaluation methodology for predicting and assessing the impact of development projects on land and soil. So FAO guidelines for land evaluation provides a set of principles and a methodological framework for assessing the impacts and compliance with the UN programs for sustainable development. And the USDA also outlines to carry out an EIA and need to calculate the temporary land take or soil displacement. And then you can also use predictive equations to estimate soil loss due to erosion. So you have the universal soil loss equation, the wind erosion prediction systems. So again, soil pollution can be is defined in two situations. So the first is that the site is already contaminated and a cleanup process required prior to development. And the second is that the pollution, soil pollution is resulting from the project itself or a project component. So in that case, soil pollution is again an important factor in an EIA.